Hello, welcome back to my channel Electrical Concepts. My name is Avikan Roy. So today in this video lecture I am going to talk about different methods of voltage control in power system. So first of all we need to understand why is it required to control our voltage. See, as you all know, in our mm, houses fixed 230 volt AC supply comes in, right? So suppose that voltage gets changed by some amount, so there might be some problems, or there might be some bad impacts regarding this. How? For example, voltage is increased, right? So maybe the equipments which are supposed to run on a particular 230 volts, their lifespan may be reduced due to over voltage. There might be some insulation problem, those equipments may get damaged, right, if the voltage is increased by a large amount. Similarly, if your voltage is reduced by a large extent, then definitely your performance will be very poor. Like the brightness of your lights will be very less. Your electric fans may not run at a high speed. Some equipments may not work properly. So there might be some performance issue. So definitely voltage control is important, or voltage regulation is important, but some voltage variation is acceptable. Okay, so we'll see all those things one by one. So first we need to understand that change in load results in change in current, which further results in change in voltage drop, and which finally results in the change in receiving end voltage. So for example, your load is increased suddenly, so that load will draw huge amount of current, so current will also increase. If your current is increased, the voltage drop in the transmission lines, or in the alternator synchronous impedance, or in transformer impedance, those voltage drops will be also increased. So if your voltage is getting dropped by a large amount, definitely your receiving end voltage will be reduced. Similarly, if your load is decreased, current will be decreased, voltage drop will be decreased, your receiving end voltage will be increased. Okay, so that is why change in load results in a change in voltage. The permissible voltage variation is plus minus 6%. That means if your that means it is the tolerance. If your voltage is varying within this limit, then it is okay. But if it goes beyond this range, then we need to perform some voltage regulation technique in order to bring it within the permissible limit, or in order to bring it to the desired value. Okay, so there are so many methods. Here I will give a brief idea of some of the methods, like excitation control, using tap changing transformers, using synchronous condenser, etc. So these are the methods by which you can control the voltage, you can regulate the voltage, you can fix the voltage at the receiving end at a desired value. So now let's discuss about the excitation control. What is that? See here, change in load changes the voltage drop in synchronous reactance. So basically, suppose your load is increased, okay, so definitely your current demand will be increased. So that higher current will result in a larger voltage drop in the synchronous reactance. Okay, so if your synchronous reactance is experiencing larger voltage drop, definitely the alternator terminal voltage will be reduced. Okay, so definitely it will also result in a reduced receiving end voltage. So what can we do for this? We can change the DC excitation of the alternator, okay, or we can change the field current. By doing this, what we can achieve is, suppose your load is increased, which results in a reduction in voltage, receiving end voltage. So you need to increase the voltage to the desired value. So by increasing the DC excitation, you can increase the flux, so you can automatically increase the induced EMF by the alternator. So the moment your induced EMF is increased, obviously your receiving end side voltage will also increase, and it will come back to its reference or to the desired value. Okay, so this is how by performing the DC excitation you can change or you can regulate the voltage. But there are some difficulties or the drawbacks, like this method is only suitable for short transmission lines. Why? Because in case of long transmission lines, during the journey from sending end side to receiving end side, due to the larger length of transmission line, the voltage drop becomes very high. Okay, so here the voltage drop means the voltage drop that takes place in the transmission lines. Okay, so due to that, what happens is it becomes very difficult for the authority to maintain a fixed voltage at the receiving end side, and for that they need to perform a wide range of variation in the DC excitation or in the field current. They need to vary in a large amount, so that wide range of variation in DC excitation or the field current may not be economical or the feasible. That is why it becomes very tough to perform the voltage regulation using this control technique when it comes to a long transmission lines. But in short transmission line it is okay, because due to a smaller or the lesser amount of voltage drop in the transmission line, it becomes easier for the authority to maintain a constant voltage at the receiving end side by just varying the DC excitation. So in that case, that DC excitation doesn't vary in a wide range. That range is very permissible. But when it comes to longer transmission line, that range becomes very high, which leads into an uneconomical situation, which is the limitation of this excitation control. Okay, so to overcome this drawback, we go to the next. We refer this control technique basically, which is the tap changing of transformers using tap changing transformer. So here what we do to overcome this problem of excitation control, we use the tap changing transformer method. Here we use a number of tappings in the secondary side of the transformer. So for example, if your load is increased, so definitely voltage at the receiving end side will be decreased. So then what we will do, we'll make the tap changing in such a way so that the transformer provides a larger voltage. By tap changing, what I want to say is, by changing the number of turns, tappings are varied, which further varies the voltage, because by varying the tap changing, you are changing the number of turns of the transformer, and if you change the number of turns, definitely the transformer voltage will be varied. So in case load is increased, so you have to increase the number of turns, so accordingly you perform the tap changing and your voltage will be increased. In order to reduce the voltage, you need to reduce the number of turns, accordingly perform the tap changing and your voltage will be decreased. So this is how using tap changing of transformer you can perform the voltage regulation. But there are certain drawbacks are also there, like there are two types of tap changing: on-load tap changing and the off-load tap changing. On-load means this tap changing is performed in presence of the load, but in case of off-load tap changing, the tap changing is performed by disconnecting the load. So whenever you are disconnecting the load, there is a problem of interruption of supply. Okay, this is the drawback in case of off-load tap changing transformer. Similarly, in case of on-load tap changing transformer, although there is no interruption in supply, but still the control becomes very much complex, because there if you go in detail, then you will get to see in on-load tap changing the tappings are very large. Number of tappings are twice compared to the voltage steps. Okay, so due to the large number of tappings, the control becomes very difficult. So these are some of the drawbacks of this tap changing transformers. So this is a small idea of different voltage regulation techniques. Okay, so last technique is the synchronous condenser method that I will cover in the next video lecture. So thank you so much. If you have liked this video, please comment and also subscribe to my channel. Thank you.